Hello everyone, welcome again. My name is Gabriel Starczewski and today I would like to walk you through a journey with Pester. Pester is a test automation framework for PowerShell scripts, and today I would like to show you how you can learn writing basic tests and also how to integrate the execution of Pester tests into an Azure build pipeline. You can connect with me on LinkedIn, and if you want to have a look at the code that we are going to use throughout this video, then the link is at the bottom of the slide. So before we begin with Pester, which by the way is here, that's the main page, then what's the use case for the PowerShell testing? Well, basically, very often when we automate things, then we forget about writing tests for scripts in operating system shells. So it's been quite a while that there exists a similar testing framework for shell scripts. If you write shell scripts, well, whatever they are, this is an example of a shell script. Then you can also test it with BATS framework. So for shell, this is how it looks, just a look. I glanced through, you have available a test framework, right? It's called BATS. And obviously on the other side of the mirror, we have PowerShell, so Windows technology, and we also have a test framework that allows you to write all sorts of tests, and it's called Pester, pester.dev. When do we use it? Well, in every situation when you want to test your scripts. The most common case that I'm having right now is that when I try to automate some things in CI/CD pipeline that are out of ordinary, and I'm using either Shell or PowerShell to do that, well, then it's kind of dead if I don't write tests for that. So if I write a script that automates something in a pipeline, then I also have this inclination to write some kind of test for it, be it unit test or integration test. So if you are writing a lot of automation in, say, these CI/CD pipelines, then probably you want to know that such things exist. And today you are focusing primarily and actually only on Pester for PowerShell. All right, so let's begin then. We'll need that window open, and mostly I will be showing you examples within my IntelliJ. First of all, PowerShell and installation of the framework. Here in the first script, you can have a look how to install this module. So Pester is delivered as PowerShell module. I have it already installed, and plus it requires elevated writes on my machine to install. But if you have it installed, you can check the version you have by executing get module Pester list available. So you can see that my version of Pester installed in here is 5.04. If it's missing on your machine, just install it with that command. Okay, so let's practice some things. How the basic test in Pester looks like. That's the example. So you should be familiar with it, with that structure. If you write test in JavaScript, we have describe block, context block, and it block. It contains our tests. Here is the description of the test. Context allows you to group a number of tests into one logical block, and usually it's recommended that you start this block with a when keyword. Well, that's what the context really is, and on top of it you have the main grouping, which is a describe block, so you can consider it as a suite in for your tests. So here we have 4 tests. I will run them here. I can just right click and execute it as a normal shell script, and here we have a short summary. 4 tests have passed, 0 failed, none has been skipped. Okay, what do we find inside those tests? So here you put the execution of your code, for instance, a function. and then some assertions. The way you write assertions in Pester, you can see on the screen, for instance, 1, then there's a pipe, should be 1, checks whether 1 is 1, and this way of writing assertions is very convenient because first you write something to compare against, then the pipe and the condition that should be checked. Here is the evaluation of a regex. So we are checking whether text matches regular expression text with star. This is how we check whether an array contains an element with a given value. And here we execute our function that's above, and we check whether the value it returns, which is the string foo, is actually foo. As you can see, I can write those statements with uppercase or lowercase, doesn't really matter. So this is the basic organization of tests within Pester. Let me run it once again. And all was fine. Okay, so let's move on. Now, this example contains a function that actually does something. So it's not a dummy function that just returns a string. Instead, it's a function that converts a given CSV file to a JSON file. It reads the content from a file, and then it uses internal PowerShell functions to save a file with JSON in a JSON format. So here in test data, you have an example of a CSV file, and we convert it to something that looks like this. So it's already a good function to test with Pester. So the way I organize tests, maybe I'll make it larger. We have the describe block that tells us what the tests are doing. We have a context with a when keyword, when I convert existing CSV file to a JSON file. And then we have a couple of tests and a hook that gets triggered before all tests in that describe block. So here, what I'm doing is I'm actually calling this function, and the file path I'm providing is to my test data, which I store in here. So this is a concept of run once and assert many. So I'm just running the function once in before all block, and then each of my tests just works on the result of that function. So the first one checks that the file that should be generated really exists. This is how you do it in Pester. And here we are checking whether the content of a produced file is according to what I'm expected it to be. And the last test checks, it's the repetition. Actually, I need to call it once again, because this is how you check whether the block of code true or didn't throw an exception. You put the code you want to test into a block, and then via pipe, you check whether an exception has been thrown. So I don't want an exception to be thrown. Okay, let's run those tests. And they all passed as we expected it to be. As you can see, the result of a test, which is a data JSON file, is stored in our test data. It's not a good practice, so our test should leave no side effect, and we'll deal with that case later on, what to do not to leave a trace of our test. But we are ready to move on. We have a couple of meaningful tests. One thing that's worth noting is that I'm referring to my data or to my scripts, to my data mostly, with a built-in PowerShell variable PS script root, which points to the directory, to the place where my PowerShell script is located. So it's very convenient to use that. The next thing you want to know is the hooks. So all XUnit frameworks that you can think of, whether it's JUnit, NUnit, XUnit, you name it, they offer you ability to execute some custom code before your tests, either before each test or before all of them. Pester is no different in the way that it offers you a number of hooks. You have before all hook, where you put the code you want to be executed before all the tests. After all hook, which does execute your code within the block after all the tests. And you have also before and after hooks, which do the same thing, but before each and after each test in a suite. So this is how you can use them. And here in after all hook, we are getting rid of that file. So we are executing, we are actually removing the side effect of our earlier tests. Now when I run it, test with a hook, well, tests are the same. So we have 3 past tests, but you can see we are leaving no trace in our test data folder now. So we just apply that hook. Oh, something went wrong here. Just make it. So that's an example. You can use hooks with Pester the same way you can apply hooks in any other unit test framework. But there is a better way to be dealing with things on your drive, and that's a test drive. So Pester offers you something that's called a test drive. Test drive is a special built-in variable that points to a temporary space on your disk. If you wanted to investigate where this test drive location points to, then it would point to a temp directory within your C drive mostly. You can simply use that to store data that should only be available in the lifecycle of your test suite or your tests. So what I can do in that case to make it better, I can use as a file location for the output file a location on the test drive. And this way, when the tests are done, that file will no longer be stored, which is very convenient. I can still access it in my hook, so I can also explicitly remove it, but it's not necessary. And then the refactoring that I did is that in all my tests, I'm referring to the location on the test drive, which is a temporary location. And the effect of that is that when my tests are completed, I don't need to worry about removing them, even though I'm doing that here, but that's not really necessary. So using test drive in your tests allow you to easily deal with side effects when your tests create file on a drive. Okay, so what would be the next topic? The next topic is mocking, which is very easy in Pester. To visualize how to apply mocking, I need to change my convert CSV to JSON file function to a function that calls another function that I own, which is a get file function. It just returns the content of the file. But in that case, if I want to properly test convert CSV to JSON file, so if I want to write a unit test, then I need to make that test independent of a dependency, which is get file. So in other words, I need to stub or mock it. And in Pester, you do it very easily. You are using the mock keyword, then the name of the function you want to mock, which refers to that place in the code, and then the body of the function. So that gets physically replaced. That function gets replaced for that test run with that, which means it will just okay. There was some glitch on the network, so I just waited for it to be gone. So this is how I just mocked that dependency. And down here, there's another example of a test that uses mock. And in this case, I have mocked getFile function with actually something that returns the content of that file. So even though it's very similar, I can really easily tell what that function should return so that my tests make sense, and I only test the logic of that function. Okay, so let it run with mocking. Obviously, mocking is very powerful, and you can do all sort of stuff in Pester with mocking, but that's an easiest example that you need to. Mocks also have scope, so depending on where you define the mock, whether it's at describe level, context level, or it level, it will have the scope. So you can define a mock for get file higher, and it will apply to lower level, which would be the individual test in that case. Okay. Another very convenient thing and very common thing to do in PowerShell is that when you write scripts, then the logic that is common across many scripts, or the logic that should be hidden from the user, people put in modules. In PowerShell, you can name the module with an extension PSM1, and here the module organization can be as follows. So I have two functions, and I only want to make available one function to the end user, which is a function. I do it by exporting the function from the module. And the B function that is used here is an internal function, so a user will not be able to use it. It's something that we often do in PowerShell. So I can do something like import module. It's called 005 module, and then, as you can see, I can call a function. But when I call B function, then it's not recognized, because when I imported the module, I only got access to a function. B is hidden. So this is how we organize repetitive code. We put it into a module, and it has some consequences for how we test it in Pester. So first of all, let's go in here and let's have a look at the first round of tests. That test function from within the module. So we have tests against a function. So you see on top, I'm importing this module, and from now on, I can write test against a function. So this checks whether a function returns I'm A and I'm B, which is this string. And then this test is skipped, which you can do in Pester with that keyword. So I should run like one test right now. It's a pass. This test passed OK. Now, if I simply wrote a test that tries to test B function, then it will fail, because my code does not have access to internal module function B. So how can we get that access? Well, we need to use a special keyword in module scope in Pester. Then we give the name of the module, and this will allow us to test whatever is within the module. So using that keyword will give us access to a B function. In order to prove it, I will remove the skip flag from that test, or group of tests, actually, and I will run it. And you see, now it passed. The test is B should be I'm B, which is exactly what that function returns. So an important observation is test your modules, but be wary. If some functions are not exported, then you can only test them by using in module scope keyword. But all in all, you can test all the code that you have within the module, and this is how you do it. Also, one observation is that you can put tags on your tests and then use them when you execute tests, for instance, from CI/CD pipeline, and this is how you do it. So you just put the tag keyword on top, and this group of tests will be tagged with module tests. And this brings us to how we can run tests from within the CI/CD pipeline, because when I'm in IDE, I can simply click it, and the tests are executed. But there is a special command, which is invoke Pester command, that allows you to execute tests, for instance, from CI/CD pipeline. It accepts a number of parameters. For instance, a tag filter parameter where I can tell, well, please only run or exclude tests with that tag. This command accepts the source of tests, the output file it should create, output format. You can choose any unit, XML format file, and you can also, if you are testing modules, for instance, then you can create code coverage file, report, you can say. So what's going to happen when I run it like this? Well, we should have those artifacts created. Well, I will do it again. Hopefully you can see that here. And we have just run one test that passed, one was skipped, and one was not run. So the skipped one is the one that's annotated with a skip. And then one that was not run is because we excluded that tag from running with exclude tag filter. But the artifacts that have been produced are in results, we have result file. In coverage, we have code coverage. And that's not easy to see. If I reformat that, it's an XML file with information, what lines of code have been covered, etc. And obviously, that's not intended for you to read. More, it's very useful if you want to produce a report in CI/CD pipeline based on it. And that's basically what brings us to the next topic, which is how are we going to execute tests on Azure from Azure build pipeline. And the example of pipeline is prepared for you in here in my repository. And it's a YAML file. First of all, we are creating directories where we'll be storing results and coverage report. So this corresponds to those directories. We just make sure that they exist on our build agent. Then we invoke test with Pester command. So we call this script. We used the task in Azure to publish test results. And as parameter, what we provide is an XML file that Azure can understand. And it can understand any unit format, XML format. So we are just reusing all the things that we have done so far. One extra thing that we require is a tool that will help us to generate the report with code coverage. And these are the code snippets you can use to install that tool and then generate the code coverage report, providing valid paths to code coverage, XML file, and basically test results. And the final step within the pipeline is to publish code coverage results. So that would conclude that we have run a test, we produced results, we can publish those results, and we also can produce and publish code coverage report for a module, which is great. How does it look like on Azure? On Azure, I created a Pester project, which has just this pipeline. I can show you how to create it. Which is something that I'm sure you are confident with, but for sake of completeness, I'm defining the source of this pipeline to point to my 007 Azure YAML file. I will save it for you. And now I can run it. And all the things that you've been able to see in here, all the steps will take place. So let's go in here and let's see what happens step by step. And what happens is the build gets executed on a build agent, and I'm choosing the image Windows. It's a hosted agent. We check out the repository where our pipeline is. We create directories. We run Pester tests with invoke Pester command via the script that you've been able to see in here. So that's the script I'm calling. Now, when the tests are run, I'm publishing the test results because they are produced as an unit file within my Azure DevOps project. I'm installing code coverage tool on the fly on the build agent, which is very convenient. Once this tool is installed, I'm creating code coverage report based on the results from earlier steps, and I'm publishing a code coverage report, and it's done. And I have just successfully run tests for my module defined by in a PowerShell file, and I produced test results. And I also produced code coverage report, which is great. So in here you'll find tests. I can just display all of them. And as you can see, these are tests from within our test file. And I also produced code coverage report in Java code coverage format. So it's a JCOCO format. And this way, what you achieved is CI/CD pipeline, because basically that's a CI/CD pipeline, and I can prove it by making a very small change in here and committing. That not only runs your tests against the module where your code exists, but also produces test results and code coverage report, which is everything you need in order to actually be successful when you write PowerShell scripts. So you see another job kicked in, which was driven by my commit, and the test will run again. So now you have a very powerful mechanism or framework in order to actually write tests for your code. And I would strongly recommend that you do that, because what I'm observing nowadays is that many DevOps SREs, they do all sorts of automation in Shell or PowerShell, but they forget that we also have test frameworks for those, and we should do it. Because if you don't write tests for our shell scripts, then we incur debt, and that debt will take revenge on us in the future. Some tips from my side for you is that when you do write tests for Azure automation, for instance, then first of all, if possible, use Azure existing stats to do what you want, and only write your own logic in a script if you need to. So here, try to do that rather than doing something like this. That's my first recommendation. Second, when you develop custom logic for your pipeline, put it in a script and not as an inline element, because if you do it like this, then this is testable. You can write tests for it, but you cannot write really tests for inline scripting. So in our pipeline, I gave you examples, something you should avoid and something you should follow. And also, if something can be generalized, then maybe it's worth writing a task for Azure. So think about it. You can also have a look at real-life example in here. This is a real-life example of a custom automation on Azure. It consists of a YAML step that calls a script, which is a PowerShell script. We have a mock for that step in the pipeline. We have a PowerShell script that uses functions from PowerShell module. Just a quick glance. So we have a script that uses module, and then we have a corresponding test for that script and module code as well. So the content is not important, but here you can have a look at a real-life example. Just for curious, this is part of a framework for performance tests with JMeter and Kubernetes on Azure. And this particular step runs tests from within the Docker container or on a Azure build agent. But as I said, what's inside is not so important, but the organization might inspire you to follow the same principles in here. And that's what I wanted to show you and share today with you. So thank you for being with me today. If you want to connect with me, then you can do it via LinkedIn, and the code for this example is available on my GitHub, which is available in here. So thank you a lot, and hope to see you next time.